Lua in Erlang. So, hello, I'm Jan Chazul. I came from a tropical paradise called Costa Rica, and today I will talk to you a little bit about an implementation of Lua inside the Erlang virtual machine. So, Luerl is an implementation of standard Lua written in Erlang OTP. Lua is a powerful, efficient, as you know, lightweight, embeddable scripting language that is common in games, Internet of Things devices, scientific computing research, and supports, well, almost everything. You can do procedural programming, object-oriented programming with it, functional programming, and, well, almost everything. A little bit about Lua. Lua was born out of necessity, initially developed as a result of strict trade barriers instituted by the Brazilian government. Apparently around that time, you cannot import software, so they built this language for their own purpose. Was created by Roberto Jerusalimsky, Luis Enrique de Figueiredo, and Walter Marcellus at the Pontifical Catholic University of Rio. Lua is portable, is very small, is simple. In portability, you can find Lua inside NetBSD kernel, inside the Olivetti printers. You can find Lua inside your car dashboard if you own a Mercedes or a Volvo. It's basically everywhere. It's simple and have a strong emphasis on scripting. Lua is very simple. It only has very few power mechanisms like associative arrays to implement all data structures called tables. Have closures, which are first-class anonymous functions with lexical scope. That's kind of the technicality. And coroutines, one-shot continuations. But in the case of Luerl, we really don't interact or have coroutines in the implementation, because what we use are the capabilities that the Beam virtual machine gives us to exploit multiple processes at the same time. It's a scripting language used to control other languages in the sense not of other dynamic languages like Python or Perl, but in the sense of Unix shells. With Lua, you always have like a program that is all the time written in two different languages. You have the system language, which give you like the stable parts of your application, the algorithms and data structure, and you usually use Lua as the scripting language in the flexible and easy parts of your development. Erlang is a concurrent functional language that runs on his own scalable, fault-tolerant, real-time virtual machine called the Beam. It was created in the 80s by the team of Mike Williams, Robert Birding, and Joe Armstrong at the Ericsson Computing Science Lab. It was later released as open source in the 82, thanks to an effort of a group led by Jane Waldrop. The problem domain that they had in the 80s was telephony. So they have a switch called the AXE, and apparently it was very cumbersome to develop and maintain, so they have a problem. They need to find a replacement, or at least develop some tool and some system with all of these capabilities, something that maintains massive concurrency, something that is fault tolerant with timing constraint. Apparently, if you are a telecom company and you sell equipment, you paid a lot of cash, you know, if you broke all these constraints, they are in your contract, so it's very important issue. You need the capability to continue operating the system, and you can't shut it down at any time. Like, you know, if you take a phone, you expect always to have line. It's not that you have like the time frame at 12 o'clock to restore all the country communications. So they have this problem, and Erlang is the result of that problem. It's not an academic implementation of a functional language, and it's not an academic implementation of the actor model. They later discovered the Carl Hewitt's papers and compare, but it's not that they were pursuing that goal. So what is the BIM? Basically, the BIM is a virtual machine that runs Erlang. That's it. It has some internal properties that you basically don't need to worry about. It gives you this massive concurrency, asynchronous communication, multiple processes isolated from each other. You have error handling capabilities, the feature to hot code reload at any time, and support introspection and monitoring. You only have to worry about sending and receiving messages. And it also has some external properties, which is what the developers see or interact with. You have immutable data, a strong parallel machine. It's a functional language with a predefined set of data types. You have modules as the unit of encapsulating code, and no global data. When you develop Erlang, there is this thing called the OTP, which is basically the framework that you use if you are an Erlang developer to make your things. It's a collection of libraries and tools. It basically gives you the concept of an application and different behaviors like finite state machines, the client and server abstraction. You have like supervision trees and that sort of things. In this environment, we have what we call the BIM ecosystem, which are different languages that are built to live inside and interact with Erlang and OTP, and the BIM at the lowest level of the infrastructure, that again is just a virtual machine to run Erlang. It's very, Lua in the other side is famous for give you mechanisms and not policies. It's a simple language with simple concepts that provide you the mechanisms to implement the rest of the fancy features that you might need, instead of provide all of that directly to you. It also have like an ecosystem, like the standard official Lua from Brazil, Lua JIT and Raptor JIT, Moonscript, which is kind of a different language built on top, and Luerl, which is the reason that I'm here, and many more implementations. The goal of Luerl is give you a proper implementation of the Lua language. So what Robert Building, the creator of Luerl, was looking when he created this project, was not built a language that is like Lua on the Beam, but is give you the complete native Lua, but for this ecosystem. Like the standard Lua, Luerl is implemented as a library. The Beam is a mixture of interpreting Lua virtual machine instructions using Erlang directly to implement function calls. One additional of the features that you might have on common native Lua, it gives you fast language switch between Erlang and Lua. It exploits the capabilities of the Beam virtual machine, give you the way to transparently utilize your multi-core machines. So Luerl is a complete reimplementation of the Lua language, including an Erlang API that matches the C API available on the standard Lua. Some trade-off of both languages. Lua is commonly not good for concurrency and multi-core parallelisms. The standard library is not very large and give you a do-it-yourself approach to life, which is not a very bad thing. It's just the way it works. Lua is not good. Erlang is not good for heavy number crunching, global share mutable state, or your common desktop Wii application or mobiles. The result of this implementation gives you a complete Lua that offers great interaction not only between Erlang, but Elixir, LFE, and all the rest of our friends on this ecosystem. In the implementation or using Luerl, we keep our Lua state in one data structure and we explicitly thread it through everything. This threading of stuff is what we typically do in Erlang anyway. With that in mind, it's similar of what Roberto Jerusalimsky called the eye of the needle approach, which is using all these mechanisms that Lua gives you to try it in your head to see how you need to use them to, like with the eye of the needle example, pass all your data structures and your code around that, the API. Luerl embraces both LuaLAN and Erlang communities, and I guess my goal of this presentation is at least spark your curiosity to check it out, to learn more about Erlang, to use more Lua inside that ecosystem. I personally believe that both communities are very simple, diverse, and complementary, and great languages. That's my presentation, so thank you. And if you are interested,
well done. You can take some questions, John, and then the next speaker will set up.
All right, so any question? No? All right. Yes.
Do you have some example code?
Not with me, but I can show you outside in the, not right here in the presentation, but for sure.
So Lua is a dynamically typed language, right?
It is.
Which I've just explained.
It is.
How does it fit with the Beam? Because the Erlang is very statically typed.
It is. So Robert builds his own Lua virtual machine in top of the Beam. So you interpret code and it's interpreted, exactly. There is an interpreter and a virtual machine implementation. So, yes?
Which version of Lua is it now?
Right now is right now we are currently working on the 5.3 implementation, and I think there is ready for prime time, but we need users and we need all the help that we can get with the bug reporting. So you are welcome to check it out. That's it.
Thank you.